Hey, before I begin, just a little note about the images that you're going to see because I pulled them directly from the web and I'm not sure if the license explicitly prohibits any kind of other use, so I hope that's all fair use what I'm doing here. That said, hello, my name is Sebastian and I do suck at programming. And you might say, well, maybe everybody sucks a bit at programming, but I believe I suck particularly badly. So why am I saying that? So even when I try to do something very simple, let's have a function here that does a plus b, and apparently my terminal here, my console here remembers a few things that it did before. Then I think that will work. So that seems to work quite fine, even with floating points that works fine. But what happens now? That is like a real now. That's amazing. I didn't expect that. What about now? Okay, things get a bit odd and even odder. Well, of course my intent was to only be able to add numbers here and everything else doesn't really yield any results, but I was unable to express that intent. Also, the language doesn't really care about that apparently because it just does something. Changing the return type from a number to a string, for instance, and so on. And you could say, well, that's part of what JavaScript is, and it's not your fault. But I think if I don't want to suck at programming, I can write programs that behave in a controlled fashion at all times. And I'm just unable to do this most of the time. And yeah, if I think about all these cases that I have to handle in a way, exceptions can creep up on you at all times. And if I get started with nulls, then it's getting, I get furious and angry. So I'm really unsure how I can be ever a decent programmer with certain kinds of tools that I have to use all day long. Knowing that there are tools out there that will fix that for me. They have strong type systems and basically allow you at compile time to prove that your program is sound, that it will work, that it will not have any kind of undefined behavior or weirdness happening at runtime, which is really the problem here. Stuff can happen at compile time, then you fix it, and then it will never show up at runtime again. So these functional programming languages, like Haskell, for instance, they happen to do a lot for you, right? I don't know Haskell myself because, yeah, as you can see, it looks a bit special compared to the common languages, let's say, that you learn in school or that you use most of the time. There's Lisp here. It's kind of the same as this hailstone sequence. I don't even know what that is, but apparently that's how that looks like in Lisp. So lots of parentheses here. And OCaml. I don't know why that is so long. I really have no idea. There's much more going on here. And I do believe that all these will make it real hard for you to mess up the runtime, just because they're made to be sound. Oops. However, everybody could just write in these languages, but we don't do that because they look very alien to us. They look odd, and it probably takes some time to getting used to that. And many of us don't do that. Even I didn't do it yet, even though functional programming was kind of creeping into my thinking and also into the languages I'm using from day to day. But it's kind of tagged on then, right? But at least you know what these languages could do for you if you would use them. The good thing is that you don't really have to go all alien. You can go part alien and have a look at Rust. I know. I consider myself a Rust advocate just because this language changed my life, because it managed to give you all the performance in the world while not being unsafe. So this language forces you to be safe. It forces you to be to write sound programs, and the compiler tells you everything at compile time if something is wrong with your program, and that's super awesome. You have kind of this godlike figure that is helping you whenever you hit the compile button, and you can trust it. In Rust, you can trust. That's kind of what I'm saying. So here is the playground. I run it locally, and a simple hello world, which actually works. Cool. So let's try to do the example again. So we have an add function here. I want to add a, which is a, well, I guess in 64. And there is a b that is an N64 as well. And we want to return an N64. Actually, I'm not sure anymore how how the syntax is here and how the primitive types are. So what about this? What about a plus b? Does this make any sense? Let's try. So as you can see, it's a statically typed language. This means that you have to specify the types that you want to use in your function signatures in order to tell the compiler what it has to, assure for you. So right now, if I wanted to stuff in anything else in there, I might have a problem. But let's see. Let's see what happens if I say add 1 plus 3. Does this work as expected? And it does. Okay, let's mess it up a bit. Let's put a character in here or a string. Oh, and I would expect the compiler to tell me that something is wrong. Okay, this is just standard in the sense that any statically typed language has that. But in the case of Rust, you're talking about a type system that is so strong that you can specify your intent so precisely that, I mean, you will feel unsafe in any other language where exceptions can creep up on you, where nulls can creep up on you. This won't happen here. You have perfect control over your memory. But also this comes at a cost, right? You have to learn a lot. You have to get used to ownership tracking, even though it's awesome and you want to do this in any language, basically, because you want to know who is mutating what at which time. But yeah, it really doesn't come for free. And I'm still not at the point where I would say that I understand this language in any which way, because it can get very complex. As here, for instance. Like this, now you start with generics and you start with lifetimes and trait bounds and stuff. And even though you wanna have that in order to write generic code, in order to have more versatile functions there or better APIs in that sense, for the API writer, it's way more complex, let's say. But on the bright side, you tell the compiler everything you want. You state your intent, and it will assure that certain invariants are always true, basically. So that's awesome, but it's quite hard to learn. So I was still looking. Rust wasn't the last thing I will ever look at, because I was still looking for a simple Rust, which is garbage collector. Because I think with garbage collection, you can get rid of lots of complexities that Rust has like lifetime management that is partially manual, and ownership is a good thing. However, all these concepts they kind of add to the cognitive load. It should be statically typed, because I want to see errors or mistakes they made at compile time, not at runtime. That's very important to me. With strong type inference, because I don't want to type out that stuff. It's about ergonomics here. So Rust does have very strong type inference, very good type inference, so that's awesome. This makes it very usable. But I definitely need that. Yeah. No nulls, please. Never, ever again. And also no exceptions. I don't think I wrote that here, but exceptions are terrible if they can creep up on you at all times. I want to have explicit error handling at all times. And yeah, I don't want to pay for it. This should be free, basically. Rivals see in performance? Yes, why not? Please do so. So I want to have all the benefits without disadvantages. I want a simple Rust. Garbage collection is fine in that case. And this is where you should meet Krystal. Yes. Krystal is this awesome new language. I don't know how new it is particularly. I think it's 4 years old. It's made by a Brazilian company or some people that work in that company. And as you can see, it's... I'm not quite sure. Please, Siri, stop that. Siri just listened in and thought she understood something, and there we go. Destroyed my presentation. But maybe that's also funny, so I shall just keep glossing over it and keep going here. So Krystal is basically looking like Ruby, but it's statically type checked and really fast, and has a lot of flexibility, considering that is kind of a statically checked language, and it also compiles down to native code, right? So you would expect that there are some trade-offs, but actually it doesn't look like it. So look at that. That's the simple HTTP server. I think it looks quite similar in Ruby. And yeah, it's also, it's also a very young language in that sense, but that doesn't really do anything for me, in the sense of I would use it right away, and I spend a weekend with it, and this is kind of the gist of what I'm going to show you today. Yeah, I don't know why that happens. So here we go with the Krystal playground. Oh yeah, that's how it comes up. I shall just execute this in the playground real quick. And as you can see, even this kind of simple web-based playground, it has all these fancy features where it can show you all the values within a loop and all the types that happen to be present or inferred at some point. So I don't have to specifically add type signatures here. They're just inferred based on the way you actually use that function. So basically at instantiation time, at a time of usage of a function, the compiler starts to do all this inference work for you and determines that at the end of this, you could have an int32 or a nil. And what this means, we will learn in a moment when I try to write this add function again. So add AB, and there's an end here. Then I guess it's a plus b. That's how it is. And then what if I say 1 plus 2 here? How does that work? Okay, that's 3 as expected. How does it deal with floating points? Okay, now it's a float, but this doesn't really, this happens on per invocation level, right? So if I invoke it with integers, I get back an integer. Otherwise, I get back a float. And let's see if we can even do some odd things to it. Does that work? Oh, look, no overload matches int32 plus with a string. So I can add a string to an integer, which is very nice. And it tells me that at compile time. It's actually pretty neat. Also, this UI, I mean, it's a web thing, and it kind of looks like a little IDE here that is quite usable. I'm really surprised, or I was really surprised when I first have seen this. And yeah, you can have that right away. It's super easy, but we will talk about that in a moment. So that's how it works, basically. And one could be inclined to say, well, do I now have to be strict about my return values? Or can I return whatever I want and we'll just figure it out? So let's see. If if b is 0, then we want to explicitly return here and return nil. So there's this pesky nil again that I didn't want anymore in any language, but here it is. So how can we deal with that? Well, I kind of don't like nil. I think I have to be more precise. If it can creep up on me, if I'm really not sure whether there's a nil in my stored in my variable slot there, or if it's what I think it is. So if I now re-execute this, oh yeah, so maybe I just take this out. Then you will see that all of a sudden my return type changed to a union type. So this is kind of a tagged union. So it's any of these types, but only one of them at a time. So it's an int32 or a nil. So what does it mean if I wanted to work with that now? So if I store this in a variable here and I want to now add another 10 to that x, what happens? Oh, undefined method plus for nil. So compile time type is either an int32 or a nil, and if both or all of these possible types that are in there, if they support a plus, then you can do it. But if one of them doesn't, then you cannot do it anymore, because then this operation is unsound, because there's this one possibility in there that makes this fail. So how could I circumvent this? Maybe I can do a type check. So if x is a, so this is like Ruby, I think, is a int32, then do this. Should I indent this just for visuals? Maybe. So now you can see that there's a 13 here, because within that branch, the compiler knows, oh, that can only be an int32, because it's smart about this. I don't know how it does it really, but it can do it. That's pretty awesome. And there's another way to do it. You could also say if x. Oh no, wait, not with if. You can do a more functional style, which I would prefer in that case, I guess. So if just try is basically showing that if there is anything in there, if there is a possibility of being a nil, then take whatever is in there, and then you say x plus 20, and go ahead. This should also work, see? So now there's 23 in here. That's nice. And if I should put something like 0 here, then all these branches will not be executed because I actually can't do this on a nil. So that's pretty fantastic. I mean, it combines all the best of all the worlds, and is also fast. I mean, yeah, I'm getting ahead of myself. So let's have a look at even more code. So what about classes? All right, classes are kind of these reference types. So you can have a class that could be a point that has a property x and y. And these x and y, so properties basically just are shorthand for setters and getters. So like in Ruby, you can't expose fields of your classes or structures directly, but instead you need access functions for that, and that's what property does. But that's a constructor here. So I don't know how far that would go. We could actually go try it step by step. What happens now? What do we get? So we get a point here which has apparently nothing in it. What is happening if I want to assign this to assign this? So it has a problem because it can't infer the instance variable x of the point, because you want to actually tell him now what you expect here. So if I say it's supposed to be an int32, then for both of them, by the way, that's kind of the shorthand, then this should work. So if I just print this out directly, then nothing happens. I think that's kind of a shortcoming, because in a way the way this usually works, if you say that you want to initialize these guys, then you could say I want to initialize this with 0, and y should also be 0. It's kind of a default constructor that just gives you a 0 point. And now I would expect something to happen here. Yes, everything is an expression, by the way. So like in Ruby, there are implicit returns, and your if condition is an expression, and switches or matches can be an expression. So as you can see here, it's one particular instance. It's passed by reference, which actually you don't see right now. And that's interesting. Why is nil right now? That's a bit surprising. Is that actually true? So because it should be null. That's the default. It's int32 or nil. I think because of this, maybe because I didn't initialize it here, or didn't say that it can actually only be an int32 ever. So yeah, I think I ran into something that I don't understand entirely yet, because I've done that before, and actually it used to work, but I think it yeah, maybe it's because it's a class. All right, so here are reference types. Here are reference types, and these have the disadvantage that they can be mutated by everyone. They're always passed by reference. If they have a function here, like def, let's put this here maybe, I'm not sure. That makes a difference. So if we increment x and we get a point p and an amount by which we want to increment it, then we can do it like this. We return p, and p.x is incremented by the amount. So now you can call it like that and say increment x, hand it a p, and then by what? By 10 maybe, yes. And now I get a new p here that should, oh, instance variable y of point was not initialized. Can you do that again? Rendering it nullable. in all of the initialize methods. I thought I did that here, right here. Initialize, there we go. Haha, cool. So now it is actually showing the thing that I would expect, and now you can get rid of that because the type is inferred. So by default, it's just int32 if you don't specify anything when putting an integer there, an integer literal. Cool. So that addition actually worked. That's not unexpected. However, it mutated my instance. So that function here is a side effect. So if you want to go functional, then you want to have pure functions that do not have a side effect. Also, if you want to be fast, you don't want to have these reference counted class types everywhere, because they will always go to the heap. And if you have a million of that, that's lots of pressure for the garbage collector. So let's have a struct to the rescue. Structs are value types. So they have similar semantics as a class. You can do the same thing with them, but they're value types. So now if I just execute the same code, you will see that my original x has not been modified, but instead I'm getting a new point out of that. Why? Because it was copied in here, it was copied by value. So this function cannot affect the outside world at all, and that's awesome. This makes it really easy to test and to test a program. Right? This is why immutable data structures are so fantastic, and this is why it's so fantastic to control mutability of your state specifically. So Rust, for instance, does that particularly well without forcing you into immutable data structures and without forcing you to copy everything, which also comes at a cost. But we all know that it doesn't come for free in the sense of cognitive load. So sometimes you just want to have this, and you say, well, that's still pretty good for a language that is so high level, to actually offer that. So that is that. That's the kind of little minor overview of the language. There's much more to be shown here, but of course there's not enough time. There are coroutines implemented, so it's like they're called fibers. So you can have cheap asynchronous events or things that can run from time to time. So it's cooperative multitasking, I think, because these fibers, they kind of hand over to the next when they know they would block. But anyway, there's more on the website and the manual if you want to learn about how this is implemented. But it's really good to have that already, even though it's just 0.18. Okay, before I continue rambling, let's just move on to the next big topic, which is the ecosystem. That is very important with a language, right? So if you have a fantastic language, but it's super difficult to do anything with it, then, well, it's probably not the language you want to use next time. But let's go to the playground. So I just shut down this thing here, and want to be here actually, because here is my Krystal playground. So you might ask, oh, actually, let me boost the size of this just a tiny bit. So when you've seen the website that I could use to basically test out my code, this is just Krystal play. This is how you get it. Boom, there it is. Nothing to be done. In order to install Krystal on a Mac, you say boom install Krystal, and you're done. So it's that easy if you want to give it a shot. And then you have this wonderful Krystal binary that adheres to the command subcommand pattern, which makes it really easy to use. It's fully documented, and honestly, it's just the way you would expect it to be. So as you can see, you can initialize a new project, build stuff, handle your dependencies, just evaluate code, get the playground, run it, run your specs. So there's a test runner in it. You can use any kind of the provided tools to get information about your types, or even format your code to have the kind of adhere to the standard format that comes with the language usually. And Go FMT is quite popular because you don't have to care about so many things then. And Rust FMT is there as well, and they have it too. They have everything, it seems, right from the start. It's too good to be true sometimes. So I don't know. There's a catch here at some point. So let's create a new project. Let's say I want to init a new application that is hello. Yeah, I've got a hello already, hello world. Then here's our hello world. This is how it looks like. So there's everything you need, which includes a Travis file. Yes, so you can run or set up Travis for a project right away. There's much in it, as you can see. It just Travis knows Krystal, and so they can work with each other. The shard YAML, I think that's the project specification. So he would say what kind of version you have, how it's named, and lots of metadata about your project. For upload to, I think it's krystalshards.xyz. I think that's the official website for uploading shards, which is like a package, which is like a library, which is what other people can specify as their dependency to have the dependency manager figure out the details for you. So what else is there? We have a spec already, and I guess the first thing you do for your kind of hello world is to run the specs. Let's see how that looks like. Oh, it looks Ruby-esque, very nice, I think. And if you have a look, yeah, I'm not sure if Vim is the best editor for this. I mean, tooling support, because it doesn't really know that it's Krystal. I don't have anything installed here. You can usually use the Ruby syntax to get decent highlighting. So that's how basically the application looks like right now. And if you want to go to the spec, then this hello world spec should contain the describe blocks and add blocks, and you would probably fix it up and make it false. And then we fixed our test, and maybe I just put a real hello world in there with a put as hello world. There we go. And now if I decide to run this, Krystal run, I think, should do it. Yeah, it wants to have the kind of program file, the startup, the main thing. It doesn't know this yet from just the shard or so. I think that was a bit unexpected, because if you use Rust and Cargo, then it will basically know what's going on and will just do the right thing for you. Here you basically specify the main file that will pull in all the other requirements that you might have there. So that's a hello world. That was easy. And now, just to indicate why I'm so fascinated by this, if I should build this hello world program, then you get this hello world binary, which by default is just 212 kilobytes in size, and it's real fast, because there's nothing really there's no baggage it comes with. If you wanted to, I mean, that's not even as good as it can do, because by default it only does debug builds, which basically tells LLVM not to optimize anything really. This produces bigger binaries, which can be quite slow, but it produces them fast. So if you want to run all the optimizations there to have the fastest possible kind of release binaries that you want to ship to people, then it's down to 76 kilobytes for Hello World out of the box. And interestingly, not even Rust does this. I think with Rust you're a bit bigger. But of course, that's not all. That's not the whole story, right? It's also about the kind of dependencies that you have. And there are a few. And these are the ones that could be a bit problematic here. These ones that are, the garbage, the Berm garbage collector, for instance, and lib event, everything in user local is kind of my stuff that I installed separately. And that would make it a bit less portable, right? So at least some of these dilibs you would have to ship with the program if you wanted to be sure it works, or you containerize it. I don't consider it a big problem, but I just compare to Go, for instance, where there is nothing showing up if you would do that, because it's totally standalone, which makes it totally portable as well, which is pretty neat. But it's nothing is ever perfect in every which way. There are trade-offs, and this is a minor one that I'm still very, very, very happy about this. So the next thing I would like to talk about is, or show basically, is performance. So let's copy some binaries, some programs here, which really is just a Mandelbrot generator. We have one for Ruby. I downloaded that from, I think, Computer Language Shootout, and the respective version for Krystal. So let's have a look. Oops, let's have a look at the Mandelbrot CR. And yeah, you can see that it looks really, really neat. That's already it. It's 40 lines of code, and there's not much of type annotations going on here, except for one U8 up there and this line. So really ergonomic, and it looks really good, I think. That is a Mandelbrot here. Means if I would want to execute that, then I would say bin Mandelbrot CR. And I think you also specify the amount of iterations that you want to take. And you also want to run it in release mode, I suppose. And the resulting image, I do not want to see. It's kind of a little Mandelbrot, 100 pixels wide. And the entire call now took 2 seconds because we also have the compilation step in there. So I guess what we really would want to do is to build this, to have this beautiful release program here that will then run or start running right away if we execute it. So let's give it the same treatment as before. So that's way too fast. Let's give it maybe 200 or 300. It's still too fast. So that's better. So it's 0.1 seconds here for 1000 by 1000 pixels of a black and white Mandelbrot set. So it's really simple. And the same thing can be done for the Ruby version. Let's see how that will fare. Of course, it's a bit of a mean comparison, just because it's kind of a different program. It's really much more complex and complicated and kind of optimized for many things. But if I want to run this now, then you see that it easily takes 30 times longer than the respective Krystal version. And because it's kind of so optimized, or optimized for some things, I don't know really what, but you know, it's not just standard. It's not what you would expect. There's lots of stuff going on, classes even for some reason, or namespace, I don't know. So it's really way more. But here's kind of the core algorithm, and I guess that's what does the bulk of the job, if considering that we don't even use multi-threading here. Or it's also for Java and whatnot, I don't know. So it's way more complicated, hardly comparable, but I think the main loop is still as optimized as it could be. And of course it's way slower because, yeah, you can't beat that. LLVM just gives you the optimized machine code that is as fast as C could be, possibly, just because the types used here are just basic or primitive types, and you would do the same thing in C, for instance. So it really boils down to being the same or very similar thing, you know. And that's totally awesome. So you have the choice now. And I think that should be it for the little tour of Krystal. As you can see, the Krystal binary is basically your main entry point. And just for completeness, when I first held this presentation at the ThoughtWorks Brownback 2 days ago, there were many interesting questions, and one of them was, okay, would you actually want to use this in project? And I say, well, if you spike it to be sure that kind of the libraries that you need, the stuff that you want is there, and that this is generally working, then I think, of course, you can use it, provided that you vendorize everything. Because, you know, with such a young system, the problem could be that you hit bugs. That can always happen, though, even with a mature or old or stable system. And what will happen is that everything changes all the time, right? So you're hunting dependencies there and kind of trying to hit the bullet in flight, which is difficult and cumbersome, and you don't want that. So vendorization is what you want to do. And I would even go as far as to vendorize the main, and that's kind of the point that I'm making, to vendorize the compiler, the Krystal compiler. So the cool thing is that all you have to do is to basically keep track of the commit of the Krystal repository, and then in order to build the Krystal compiler, you just hit make. Really, that's it. and it works. And you can also make tests and then or use Krystal then to run the tests to run the specs on the compiler, so you know it's actually sound, and that is that easy. I mean, sure, the main dependency that it has, I think it's LLVM, but once you have installed that, you are good. And really, to me, it was as easy as cloning this repository and hitting make, and this worked out of the box. And just compare that with Rust, which just takes way longer to do the same thing. It kind of works, but it's massively more complex. Oh look, I just built the compiler. And this is how you vendorize your compiler. This is how you assure that it will not change unnecessarily and that every dev uses the same thing. And if you combine that with something like Docker or just some container solution, then you know that you can ship your stuff and it will be what you expect it will be, and you will not have to be afraid. And you can still, this would allow you to use such a great tool already without the fear of stuff breaking all the time, while producing code that kind of looks like Ruby, right? And this is easy on the eyes usually. And that's totally awesome. And I would really, I mean, we have the technology to do all this. There's no reason to argue that, oh, it's immature, it's still below 1, you can't use this possibly. Yes, you can. What are these microservices all about if you can't use the best tool for the job? And sometimes the best tool is something like that. And that's just my take on it. Just be as flexible as you can be. Technology allows it nowadays. So yeah, that's my 2 cents about Krystal. I hope you like it, and I mean you like Krystal because it's I think it's actually very, very nice. Please have a look, krystal-lang.org, and while you're at it, you could also have a look at rustlang.org if you want to have a less simple kind of Krystal. So thanks for watching and have a great day.